Welcome to another exciting episode of CS Teaching Talks, where research meets reality. I'm your host, Dr. Emily Tomford, and when I'm not reading papers here or discussing them with friends, you can find me teaching computer science to pre-service teachers at Reach University. In this episode, we'll be discussing the paper, Understanding the Link Between Computer Science Instruction and Reading and Math Performance. It's by Jean Salac, Kathy Thomas, Chloe Butler, and Diana Franklin, and it was published in the 2021 proceedings of the ACM Conference on Innovation and Technology in CS Education. I'm delighted to welcome this week's guests.
My name is Zoe. I am a high school science teacher.
My name is Patrick Hester. I use he, him pronouns. I work at a company called Codio. We're a computer science education platform, and I'm on the content team.
Hi, I'm Elizabeth Bacon, and I work at a computing and robotics education organization. She and they for pronouns are both great.
Hi, I'm Jason Zagami from Australia at Griffith University. I'm an academic and use the pronouns we, us, ours.
So the article we're looking at this week is called Understanding the Link Between Computer Science Instruction and Reading and Math Performance. This is out of the University of Chicago and is associated with Scratch Act 1, Scratch Encore, that great lab out of there, run by Diana Franklin. Okay, let's attempt a summary. What was this paper setting out to do?
The paper was interested in wondering if you taught CS to students, would you see an improvement on reading and math scores? And they're talking about standardized tests. So they had a group of fourth grade students, and they had a couple different groups. They had, I think they called it like more open-ended computer science, and again, with Scratch. Then they had the tip and see, and I believe it's out of the same institution. And that is a much more structured, much more deliberate way of going over like use, modify, create. And then they had the group of students that didn't have any CS courses. And then they took the STAR test in math and reading. And what they found was, and then they also had disadvantaged students. They had like economically disadvantaged students, bilingual students, and then students with disabilities. And what they found was that there is no statistically significance between computer science and reading scores. There is a very minor one with math, and that held true for students that were economically disadvantaged. It's held true for bilingual students.
I want to talk a little bit about the argument that they made in the introduction about what motivated them to come up with their research questions. I'd like to actually read a little bit out of here. That was really great. Schools can be so focused on core academic progress, particularly underperforming schools, that equitable educational opportunities for participation in content such as computer science/computational thinking may be missed. The ramifications of these missed opportunities impact long-term outcomes for college entrance, employment, and quality of life. Here is the statement that is unique to this paper. One way to increase the likelihood for inclusion of computer science/computational thinking curricula at the primary level would be to reliably demonstrate its impact on the core academic outcomes, such as reading and math, that are most valued by schools.
I understand what they're saying, and I think their heart's in the right place, but they're basically saying, like, look, the link, in the paper is how to understanding the link, and I don't think they really help us understand this link, and whatever link is tenuous at best. And so if you really wanted to get more CS into your schools, you would just play this up as much as you could and see like their scores go up. I mean, we have the numbers to prove it. We have all these fancy graphs and all these different groups, and this is wonderful. Therefore, we need it. According to this paper, you would say we have to use these unstructured Scratch activities to get possibly a very minimal bump in math scores, but not reading scores. When you could turn around and say, we're going to do tip and see, and we have much better data in terms of saying like, tip and see is better at teaching computer science. And if we want them to have CS skills, why not use the methodology that gives you better CS skills instead of something that I don't know what these unstructured Scratch activities do in terms of CS education, but it really only helps math, and it only helps math to a very small degree. So I'm not a big fan of the motivation behind that particular statement.
I want to dig into, and it doesn't have to be right now, like what exactly they meant when one group had the tip and see worksheets and the other didn't, because it sounded like Act 1 Scratch curriculum, which they were using, already includes tip and see in their introductory activities, but they don't use it in their 2 exploratory things that come after within each module. So the way that curriculum normally works is, or the way the curriculum as I read it is generally for a module, you'll have like an introductory activity, you'll have a tip and see program where they explore sort of like what that algorithmic construct is. You have 2 use modify activities that do not include tip and see, and then you have your create activity. It sounded like what they did in this is that the tip and see group added in 2 more structured tip and see in those use modify things rather than leaving them as is. I don't know if that's what they did, but that's what it sounded like. So what they didn't do was have the scaffolding gradually fall away. So it wasn't that it wasn't scaffolded, it was that it was like it was scaffolded, scaffold, drop.
Sometimes I wonder if you can just teach something because you think it's like useful or like something that they should get instead of like tying everything back to math and reading. But I do understand that because like schools, I think there has been a history of like schools being shut down because they're lower performing, in math and reading. So it kind of continues that cycle of not having equitable opportunities.
I really thought this paper kind of laid it all out. It had this weird motivation, but it was completely upfront about it, right? It was very much like, we know computer science is important, but they're not buying it. So how could we sell it to them?
I didn't have a problem with their approach here and trying to get this into schools. Lots of times they want to know how will it impact these other things that aren't computer science. I think it is important that interventions respond to the environment that, as it is, which is they don't value computer science, they value reading and maths, which, okay, that's just the truth.
I'm uneasy with selling something that I don't think you're marketing something. I don't think what they're buying is what you're marketing. If you want to sell computer science as something that is a tool that will boost these skills, then come up with a curriculum and a pedagogical structure that will do that. When I saw the tip and see paper, I was super excited and I gave it to the reading group. I still think it's fantastic. I'm not saying tip and see is wrong or they're snake oil salesmen. I'm saying what tip and see is really good at is not necessarily teaching math and reading skills, and that's fine. But if we want, a scratch-based K5, K8, whatever range group you're looking at that actually helps with math, like knowledge acquisition, then build it and then sell that.
I agree with you, but I think that's what this paper is doing in a lot of ways. They're saying, does this help math scores? Does this help reading scores? It doesn't. Bummer, and I think it's important that we see papers like that like this doesn't help. I think what was I felt like the tip and see thing was a little bit of a distraction because what I wanted to know what was happening in the classrooms where the math scores did increase. Although I respect your point, Patrick, that it's like a minimal bump. Like if you want to increase math scores, if you want to do something that's truly interdisciplinary, you should definitely do that. But I think it is worth doing this research to say, we kind of think this is true. Maybe it's true. Is it true? It's not, so that now we know.
Yeah. I think one thing they could have highlighted that they didn't, that we've actually seen highlighted in some previous papers, is giving up some of your reading and math time to teach computer science doesn't result in lower scores. Because that's a big thing. That's a fear that a lot of principals will have. Well, if we teach computer science, what do we have to give up? Are we going to go lower on the tests? And this shows that you don't go lower. I think that's a brilliant result.
Usually they categorize it as STEAM and they take away from science to teach computer science, which is what we've noticed, I guess, at like the higher, like for high school or for middle school, students come in and like they haven't learned any science in elementary because they're focused on other things, or they learn like one science lesson a week. It feels like it's fighting for the attention with computer science. So it's a little bit tricky for me, I think.
Yeah. And I think, but I might use this paper as the argument to say, look, don't take away from science. Take away from your reading and math time because you get a little bump on math. So why don't take it away from math time?
Mm-hmm. So the fact that they responded differently, I think, makes me wonder. And then they said, why did they think that their bilingual students were responding well? And they said, because they have very strong bilingual education. Well, do they not have a very strong special education program? Sometimes, especially with the pedagogical content knowledge sort of being so new in CS in elementary, maybe they don't know how to accommodate appropriately. We haven't really figured out what we need to do there. But I would say that if they're not getting what they need out of the lesson, it's definitely not going to transfer to another domain.
If we can step back just a little bit to the content around the paper, I want to unpack tip and see for a bit. I use it all the time. I get really good response to it from elementary teachers, specifically because you just throw them a new project and they're overwhelmed. There's a really high cognitive load. It's not clear what the goal is. You can immediately start to break it if you just go and play with it. So giving them a really structured approach to, like, every time I see a new Scratch project that already exists, what should I look at first? What do I care about? What questions do I ask myself? What do I do in order? It gives them a code comprehension strategy that allows them affordances for what they might do to change that code. So I think tip and see as a practice, I really love, but I don't necessarily think that it has anything to do with reading or math.
That won't show up in any standards. That won't show up in any tests. But this intrinsic motivation of, like, coding is fun and I can do all these cool things. Like, it's a wonderful spark if you can have it in your students and don't kill it with standards.
Progressive process was researched and set and everything when we were looking at, like, what age does someone have to be to understand drawing an angle on a paper? But now that angles are about which way the robot is facing, that's not being reincorporated. So, like, angles mean something to a 6-year-old now, whereas before on paper they didn't.
And I think that that's part of it. Like, the concrete affordances allow you to deal with concepts that we originally thought of as more abstract in a way that's more concrete, or maybe just a way that's more sort of accessible or relevant to the students. I've had students, and it's not just about developmental things, but students who literally, like, could not do math according to the math department. But when they were in computer science, they could. I don't know why. So I think that there are a lot of things going on that, like, maybe the mass progression is not as sacrosanct as we think. And maybe, like people are saying, like, computer science lets us do it in a way that can kind of turn our expectations on their head.
I don't think reading's ever gonna make its way in through coding. I wish they'd spent more time talking about, because I think the skills you take to read and understand code are not the same skills that you need to read and understand, like a page in a novel. It's so very different. And so I was not surprised that there was, like, no correlation between reading.
I know we love the open-ended creative projects, but the really rigid, like, solve the maze projects sometimes force kids to read more because they have to understand the instructions, they have to understand the blocks. And, like, in my experience, the benefit to reading is, if I have a kid who hates reading and avoids reading, sometimes I can interest them enough in coding to read to code. And then maybe I can give them a book about coding or Minecraft or something. And then maybe it can be their way in, not to learn to read better, just to spend more time on the actual reading. And that, as a secondary effect, their reading gets better.
I think language mediates pretty much everything. So if you're going to dig into something and really think thoughts about it and try to access information about it, like, language will benefit. And so I think I have on my bookshelf Minecraft. Like, I have a whole stack of them. It's just, like, they've been on the bookshelf for a while. I will be straight up. They have not been read. However, maybe one day. But I think for me, kind of like coming out of this paper, when we're looking at the reading and all this stuff, what I would really love to see is what is helping, because, like, and getting the complete story about what's going on in the classroom so we can dig into that.
Well, thank you for joining us for this episode of CS Teaching Talks, where we were discussing understanding the link between computer science instruction and reading and math performance by Jean Salac, Kathy Thomas, Chloe Butler, and Diana Franklin. You can find this paper and all of the others we are read and are reading at csedresearch.org, where you will also be able to find our CS teaching briefs. They're produced by our wonderful intern, Jordan Williamson, and our founder, Dr. Monica McGill. Thanks to both of you. If you'd like to participate in future discussions about CS Ed research, old and new, we would love you to join us at our discussion groups any Tuesday at 5 p.m. Pacific or Friday at 4 p.m. Pacific. And you can find all that information on our website as well. And we'd love to hear from you. Suggestions, feedback, reflections, let us know at our email podcast@csedresearch.org. The CS Teaching Talks podcast is presented by csedresearch.org and Reach University. Funding has been provided by the Association of Computing Machinery's Special Interest Group for Computer Science Education and Amazon Future Engineer. Thanks for listening, everyone. See you next time.